Hi everyone, welcome to video 3, your last video for the summer packet. What we're going to be doing here is really talking about kind of our expectations for what functions you should be very familiar with by this point kind of in your math career, ones that are going to come up over and over again as we go through calculus. So what we did is we just kind of made a list of them here and gave you the graphs. These are functions that are going to come up regularly, and the more that you just know what they look like, the more efficient some of your work is going to be. So I'm not going to go through all of these graphs. The only thing I want to mention is, along with knowing what these functions look like, you should also know how some basic transformations work. So I'm just going to pick a few and go through some basic transformations. So for example, here we have y equals the absolute value of x. We could also look at, and I'll do this in another color, let's say I gave you y equals the absolute value of x plus 2. Hopefully everyone should know that that plus 2 means we're taking this absolute value graph and we're shifting it up. So along with knowing absolute value of x, I should be able to see absolute value of x plus 2 and know that all that does is take every point and shift it up 2, so that I could quickly make a graph without having to go through and do a lot of work. Oh, I should have made this blue. Sorry about that. So that would be my absolute value of x plus 2. Same thing, if I took something like a y equals x squared that we should all be pretty familiar with, and let's say I wanted to look at y equals x plus 2 quantity squared. In this case, hopefully we all recognize that this plus 2, what that's going to do is shift the graph left 2. Even though it's a plus, a lot of times we associate that with right, but this is going to shift it left 2. So again, every point that I have here is just going to shift left. My grid's not great here, but hopefully you get the idea. That would be about here, and we could sketch this in. So again, knowing your what we call parent functions and their associated graphs is going to help you be more efficient with your work. The only other graph I want to talk about specifically is this here, y equals square root of 1 minus x squared. I want everyone to recognize this is a specific example, but a general form of this would be, let's see, can you see it down here? Let me scooch my paper up. Y equals the square root of r squared minus x squared. And that's going to be a semicircle with radius r. So for example, I could do y equals the square root, let's say, of 16 minus x squared. In that case, my r is 4, so I would just have a semicircle of radius 4. Let's see how nicely I could do that. So that's one you should be very familiar with. So really, any of these graphs that we've included in these notes are ones we should be familiar with. And here's why knowing these graphs is going to be so important. You might have on the AP exam, the AP exam has calculator and no calculator questions. So on the no calculator part of the AP exam, there might be a question that looks like this. The limit as x approaches negative infinity of x cubed. Now, if I know in my head, let's see, I know that x cubed looks like this. So then it's very easy for me to think, well, as I approach negative infinity, that limit is going to be negative infinity as well. So by knowing the basic shape of that graph, I could answer that question really quickly. Now, what if I didn't remember it? I don't want you to think that if you don't remember the shape, you have nothing to fall back on. Remember, you could always make a table. So I could do an XY table. And let's see, we'll just pick -2, -1, 0, 1, and 2. So -2 cubed would be a -8. -1 cubed is a -1. 0 would give me 0, 1 cubed is 1, and 2 cubed is 8. So then I could sketch a graph here. Let's see, I did -2, -1, 0, 1, and 2. I have to go 3, 4, 5, 6, 7, 8, and down 1, 2, 3, 4, 5, 6, 7, 8. So let's see, -2, -8, -1, -1, 0, 1, and 1, 2, and 8, right? And even though it's not the prettiest graph, I could sketch it in and then still determine that limit value. But just from that example, you can see how much quicker it is if I know the function. So let's look at the next one. We have the absolute value of x plus 2. So what I know in my head is that took the absolute value of x, which is our v, and all I did was I moved it up 2. So that point that used to be down here at 0 just moved up 2. And so now as I approach 0 from both sides, I can see I'm approaching the value of 2. Again, I could use a table if I needed to get that same graph. It's just much more efficient if I don't have to make the table. All right, number 3. 1 over x looks like this. So if I'm approaching 0 from the left, my limit is going to be -infinity. Sorry, that kind of crashed in there. So my limit is -infinity. All right, and now limit as x approaches 2 of x minus 2 quantity squared. So I know my parent function here was x squared, which is going to look like this. And I also know that this minus 2 here actually shifted it right 2. So what really happened was that my parabola that used to go through the origin here, that point has now been shifted over 2. So my graph is going to look something like this. Note again, I didn't sketch in a whole bunch of points. I'm just looking for that shape. So that now if I want to know the limit as I approach 2, I can see that from both sides. I'm going to rewrite it down here. The limit as x approaches 2 of x minus 2 quantity squared is just equal to 0. Now one thing with notation, notice here, even though we didn't have a name like f of x or g of x, right, we actually put the function name still here. We put its actual definition. So make sure, I should never see something like this, where you have the limit as x approaches a value equal to a number. You always need to include some kind of name for that function. All right, so again, you'll have some practice to do on your own. And remember, you can either do it by knowing these shapes or by making a table. But the idea is that for all of these problems, they should be no calculator problems. You should not be using a calculator to generate the graph to help you find the limit. All right, good luck. I hope you've felt pretty successful with all the work we've asked you to do so far, and I look forward to seeing you when school starts up again. Hope you're having a great summer, and I'll be seeing you soon. Thanks.